Alright, the first thing that we're going to do here is we are going to look at problem number 28 and 29. So taking a look at problem number 28, a banker is basically saying that you're going to loan you $121,000 at 7.5% interest for 30 years. And so what we're going to do is we're actually going to use our calculator, because our calculator has a special program that could help us figure out mortgages so that you can figure out exactly what this problem is asking for. So the key amounts is we're 30 years, we're paying monthly. It's hard to see that over the black. And the interest rate is 7.5, and we're borrowing $120,000, and at the end of 30 years we are going to owe nothing on this tab. So first thing I want you to do is there's a purple button that says apps. When you see apps, you will see this screen and you go ahead and you hit enter. And then when you hit enter, you will have this screen, not necessarily with the same numbers, but these are the numbers that we know. We are going to pay 360 payments because we are paying 30 years every month, so that's why that is 360. The 7.5% is the interest. The 121,000 is what we owe. This is what we're trying to find out, so this number doesn't really matter yet. This number is what we are going to owe at the end of the year, and both of these two numbers is how many times we are going to pay, which in this case is 12 times per year because we're paying monthly. Now what I want you to do is I want you to come back up to this one, which is the payment, which is what we're trying to find out, and I want you to hit the alpha button, and then I want you to hit the enter button. So when you hit alpha and then you hit enter, this is going to change. And so what this is basically telling you is that we are going to have to pay $846.05 on the mortgage. And that is basically the answer to part A. Part B says we are still going to do the exact same thing, but we are going to do a 20-year term, which means we're only going to change one number in our starting point. We are going to change this number to be 240, and then my payment becomes $974.77. To get this, you put your cursor over here, and once again you hit alpha and then enter, and it will show you the $974 after you change this to be 240. And so my answer for part B is $974.77. I'm sorry, I tried this again, and that wasn't the answer we got. This should have been $956.35. I don't know why it gave me the wrong answer the first time. But $956.35 is the correct answer. So $956.35. And so problem C says how much interest are you going to pay over the life of the mortgage. So I made 360 payments over here. So when I do 846.05 times 360, that means I paid $304,578 on a loan that was $121,000, which means I paid $183,578 in interest. Now this, I paid more money each month, which led to a grand total of me paying $229,524, and I'm going to subtract off the $121,000, and that turns out to be $108,524. So you can see that when you take out a mortgage, you are going to spend a lot of money just on interest. What's the advantage is Part D? Well, this one is smaller payments, depending on what you can afford. And this one's advantage is you paid less in interest. So the advantage is to try to pay down the mortgage as fast as you can, but if you can't afford it, then the 30-year mortgage lasts longer and doesn't cost you as much each month. In problem number 29, basically you're starting out with $0, but you're going to put $4,000 in each month, or not each month, each year for 23 years. So how much will she have to retire if it's 4.75% interest? So for this problem, 43 years, 43 payments, only one payment a year, so these change from 12 to 1. I start out with 0, and then I get 4,000. Now, to get this number here, once again you hit alpha, enter, and that's going to tell you how much money you have. So if you're able to save $4,000 a year and put it in at the end of the year, at the end of the day you will have $535,215.92. In Part B, they ask what happens if you up it to 5.25. And so for this one, I only have to change this to be 5.25%, and then the extra percentage gives me $611,592.11, all by saving $4,000 a year for 43 years. So now for the notes. E is a number. The number is 2.718281828, which you can find on your calculator by hitting the second button and then the LN button and then to the first power to give you this answer of e to the first. And so e is a special type of number because we use it for when we compound things continuously. So in example number 1, we were told that we have a formula n equals n sub 0 e to the kt, and k is positive if it's growth and negative if it's decay. So according to Newton's law, a beaker cools exponentially when removed from heat. Assume the initial temperature is 90. So I'm going to put 90 in for n sub 0 because that's where we're starting. E is a number. K is negative 0.275. T we do not know, and our new temperature we do not know. So this is my answer for A. For B, it says what happens if we cool it after 4 minutes. So I got 90e to negative 0.275 times 4. So this turns out to be 29.95, actually 96 degrees. For part C, I'm going to type in y equals 90 e to the negative 0.7275x, and in y2, and then I'm going to do second table and look at what happens when x is equal to 4. And you will see that we get the same answer of 29.96 degrees. If you want to take a look at the graph for my window, I would make my x min equal to 0 because we're not going back in time. My x max equal to 10 to see what happens through 10 minutes. I would make my y min equal to 0, and I would make my y max equal to 90 because it starts at 90 and the temperature cools. For example number 2, we only have these two equations for problem number 30. It says, compare the balance after 30 years if you have $15,000 at 12% interest compounded continuously versus compounded quarterly. So since they asked for compounded continuously first, I'm going to do the right side. 12% is 0.12, and they were going to have this for 30 years. So when I plug that into my calculator, I should wind up with an answer. Make sure that if you need to put this in parentheses to wind up with $548,973.52. Over here we have 15,000. 1 plus, my rate is still 12. Since I'm compounding quarterly, n is equal to 4, and the time is the same. Once again, put this in your calculator exactly how you see it. You may want to put parentheses around the exponent. And so this one gets you $520,664.81. Now, in the grand scheme of things, this is both a lot of money, but the difference between the two, when I subtract them, is a difference of over 28,000. So in the long run, that's how compounding continuously will help you over compounding quarterly. Your homework is 8 through 11. So here are some of the problems. Pause this if you need to, so that you don't have to go to your drive if you don't want to. And then in 5 seconds I will switch to the second page. Here's the second page. You stop at problem number 11. And if you have any questions, make sure you email me. Have a good weekend.